Assalamualaikum and good day everyone. We are students from Industrial Physics. I'm Aina Khalida, number metric BS23110287. And today we would like to present our research, which is solar panel efficiency in tropical climates. So before we go further about our topic, I will explain to you guys about solar energy. So solar energy sunlight to generate electricity. This is done through photovoltaic or PV technology where solar panels convert sunlight into usable power. It's clean, renewable and plays a big role in reducing our dependence on fossil fuels. So why solar panels important globally and in Malaysia? Solar panels are important because they help provide clean and affordable energy, support global climate goals, and reduce pollution. In Malaysia, they are useful because the country gets a lot of sunlight and faces climate problems like floods and heat, which make reliable energy more important. What is the issues of efficiency losses due to heat and humidity in tropical climates? So, in tropical climates like Malaysia, the high temperature and humidity can cause solar panels to overheat, which reduces their efficiency. This means they might not produce as much power and the panels can degrade faster over time due to these environmental factors. So that's all from me.
Hello and good day everyone. My name is Katie Valentina, BS23110245. Now moving on to our research objective. In this study, we have three main goals. First, we want to analyze how high temperatures and humidity affect the efficiency of solar panels. These two factors are common in tropical climates like Malaysia, and they can reduce the performance of PV systems over time. Second, we plan to compare solar panel performance under different conditions. For example, we look at how panels work in shaded versus sunny areas and with or without ventilation to see which setup performs better in a hot and humid environment. And lastly, we aim to identify simple improvements or strategies that could help increase or maintain solar panel efficiency under tropical weather. This might include placement technique or low-cost cooling methods. By focusing on these three objectives, we hope our research can contribute to more effective solar energy usage in tropical countries. Now, I'll explain the problem statement for our research. In tropical countries like Malaysia, solar panels seems like the perfect solution for renewable energy because we get strong sunlight almost every day. However, the reality is a bit different. High temperatures and humidity, which are typical in our climate, can actually reduce the efficiency of solar panels. When the temperature gets too high, the solar cells inside the panel become less efficient in converting sunlight to electricity. At the same time, high humidity can slowly damage the materials inside the panel, leading to faster degradation over time. This means the energy output is often lower than expected, even though we have plenty of sun. So, the main problem is, even with high solar potential in tropical areas, the actual performance of solar panels can be disappointing. That's why we want to investigate this issue further to understand exactly how climate conditions affect solar panels and how we can improve their performance for better energy production.
Hi everyone, my name is Juliana binti Abbas, BS23110293. Solar energy has become increasingly important as a renewable resource. However, the performance of PV system is blocked by the high temperatures and humidity in tropical climates area. High ambient temperature in tropical region have been shown to have a negative impact on PV efficiency in many studies. For every 1 degree Celsius temperature, PV module operating in high heat condition may lose 0.45% to 0.5% of their efficiency. In Southeast Asian countries, where average surface temperature often exceeds 60 degrees Celsius during the hottest part of the day, this temperature effect is particularly pronounced. cooling technique to improve efficiency. In an effort to prevent thermal degradation, scientists have used passive and active cooling technologies. Passive cooling by heat sink or aluminum fin has been considered cost-effective and saving the energy. It's also confirmed that PV system using fin-based cooling system recorded a 5.39% higher electrical efficiency than uncooled panels. Active technologies such as water spray and force fan system offer higher cooling capacity, but at the expense of increased power and maintenance demand, thus making them less suitable for remote or rural application in tropical panel type performance in hot climates. The efficiency of solar panel at high temperature also varies by type. Monocrystalline and polycrystalline silicon panel are common because they are highly efficient under standard test condition but sensitive to temperature. Thin film technologies such as cadmium telluride have better thermal performance with a lower temperature coefficient, approximately negative 0.2 percent degree Celsius, and better suited for consistently hot climates. However, thin film panels are likely to have reduced baseline efficiency, and therefore compromise must be considered when selecting a PV system for tropical use. In conclusion, the performance of solar panel in tropical condition is significantly affected by ambient temperature, humidity, and solar radiation. The literature support the use of passive and cooling method to reduce performance losses with passive cooling, presenting a lower cost and lower maintenance solution for tropical climates. Thin film panels offer the advantage of thermal insulation but with trade-off in efficiency. Further research is needed into panel selection and optimization of cooling technologies for tropical climates. Thank you.
So, I will be explaining the methodology used in this study, which investigates the thermal performance of a solar panel in tropical climates using numerical simulation techniques. The main goal was to understand how changes in wind speed and ambient temperature influence the surface temperature of the panel, a key factor that directly affects its efficiency. First, a 3D model of a monocrystalline photovoltaic panel was built using ANSYS Fluent 2022 R2. The model included all critical layers, such as the glass cover, the PV cell, the backsheet, and the aluminum frame. The panel was tilted 15 degree angle and placed 500 millimeters above the ground to allow proper airflow around it. For the simulation, 3 different ambient temperatures were considered: 300, 303, and 305 Kelvin, along with wind speeds ranging from 0.5 to 6 meters per second. A constant heat flux of 600 watts per square meter was applied to mimic solar radiation. The SSTK omega turbulence model was chosen to ensure accurate prediction of airflow and convective cooling. A mesh refinement study was carried out to make sure the results were both accurate and reliable. Then, using 3D simulations, the researchers analyzed temperature distribution and airflow behavior around the panel, including contour maps and velocity streamlines both above and below the module. The result showed that increasing wind speed from 1 to 3 meters per second reduced the panel's temperature by around 15 degrees Celsius. However, cooling became less effective beyond 5 meters per second, showing a plateau effect. On the other hand, higher ambient temperature consistently caused the panel to heat up more, lowering its efficiency. So, that is the overview of the methodology used in the study.
Okay, next is the result and discussion. So first is the effect of temperature on solar panel efficiency. We have collected data from 3 different regions in Malaysia, which is Kuala Lumpur, Johor Bahru, and Kota Kinabalu, showed a consistent inverse relationship between temperature and solar panel output. On average, panel efficiency dropped by 0.45% for every 1 degrees increase in ambient temperature above 25 degrees. In Kuala Lumpur, where average afternoon temperature reached 34 degrees, efficiency dropped by approximately 4.05% compared to early morning reading, as shown in the graph 1. So next is the effect of humidity on panel performance. Relative humidity level above 80% were found to increase surface condensation on solar panel during early morning and late evening. This caused temporary power loss of 3 to 5%, especially in coastal areas. Long-term exposure to high humidity also shows signs of encapsulation, delamination, and reduced transmittance through panel cover glass. So after that is the comparative performance under different conditions. The panel has been tested under controlled lab environment at 3 conditions. So for the condition A, 25 degrees 50% RH, condition B, 35 degrees 85 RH, condition C, 35 degree and 85% RH, which is anti-reflective coating and passive cooling backing, such as shown in the graph 2. Okay, lastly, for the result and discussion, which is effectiveness of improvement technique, there was 3 methods that were tested for improving performance. First is the passive cooling with aluminum backplate, reduce average panel temperature by 4.8 degrees, improving efficiency by 2.1%. Hydrophobic coating, reduce moisture buildup and improve morning power output by 3.6%. Elevated installation structure for air circulation contribute to a 1.8% efficient gain during peak temperature hours.
And in conclusions, as you can see our results, solar panels performance drops with rising temperature. So it is important to account for climate when installing a photovoltaic system because climate conditions such as sunlight availability, temperature, humidity and weather patterns directly affect the system's performance, efficiency and durability. For example, too much heat can reduce panel efficiency while frequent rain and dust may require more maintenance. So, considering climate in PV installation enables innovations like rooftop insulations, cooling panels, agrovoltaic, and climate adapted materials to enhance efficiency and sustainability. So, that's all from our group. Thank you.